Hi students, all of you welcome. Welcome to Sunil Engineering Academy. I am Sunil Kumar Bandaru. Students, in this chemistry, recently we have started periodic classification of elements. Now we are going to discuss the remaining. Let me check periodic classification of elements. Here, Lavoisier classified the elements into metals and non-metals. Dauber-Neil given triads theory. Newland's octave theory. After that, Mendeleev periodic table. After that, Henry Munsell given modern periodic table. According to him, periods are 7, groups are 18. Okay. So I have given this periodic table also in the previous. Yes. Now here how many periods I said? 7 period na. Period 1, second period, third period, fourth period, fifth period, sixth period, seventh period. Okay. So here there is a chance to get a question like in first period how many elements are there, in the second period how many elements are there. Okay, so coming to the first period, how many elements? Hydrogen, helium. So we have two elements. In the second period, here 2, here 6, total 8. Here in the third also 8. In the fourth we have 18. In the fifth we have 18. In the sixth we have total 32, and seventh period is said to be incomplete. Incomplete. So note down the point. Note down the point in the modern periodic table. Okay, coming to period and the number of elements. Number of elements. Okay, in the first period we have how many elements? 2. Second period we have 8 elements each. Sorry, second and third we have 8 elements each. So second period 8, third period also 8. Fourth period 18, and fifth period also we have 18. Sixth period 32. Seventh period is said to be incomplete. Very important question. The following which is incomplete period, that is seventh period. Okay. So here second and third having second and third having 8 elements. In the same way, fourth and fifth having 18 elements. Okay, and here in this modern periodic table, two series are separated. What are those? 57 to 71, 89 to 103. Those are lanthanoid and actinoid series. So lanthanoid series is in the 6th period, actinoid series in the 7th period. Okay, so in the 6th period we have actinoid series. Okay, in the 7th period, sorry, 6th period lanthanoid series, 7th period actinoid series. Lanthanoid series. Lanthanoid series. 7th period actinoid. Okay, so the very important questions are in the second period how many elements, in which of the period the elements are 8, second and third, which is called as incomplete period, 7th period. Okay, in which period lanthanoid and actinoid series are there? That is 6th and 7th. Okay, so those type of questions we may get. Okay, now coming to some type of elements, that is some type of elements, that is S block, B block, sorry, S block, P block, S, P, D, F. Okay, we have 4 blocks are there, you know very well. S block, P block, D block, F block. Okay, so let me discuss those in this session. Okay, now coming to types of elements. Note down the point, guys. Depending upon the type of orbital, receiving the valence electron, the elements are classified into S block, P block, D block, F block. Okay, so coming to S block elements. Which are S block elements? Group 1 and group 1, that means 1A and 2A. Group 1A and 2A are considered as S block elements. So let us take that point. In these elements, valency electrons enters in S orbital. Okay, the valence electrons enters in S orbital. Example, group 1 and 2, that is like 1A and 2A. 1A and 2A of periodic table belongs to S block. Okay, let us take any one element, then you can get understand. For example, if you take lithium atomic number is 3 now. So 1s2, 2s1. So what is the valence electron? This is the valence electron, outermost orbit. Second is the outermost orbit. Na? In that, how many valence electrons are there? 1. Okay, so that valence electrons enter in which orbital? S orbital. So that block is considered as S block. For example, let us take a sodium 11, atomic number 11. So 1s2, 2s2, 2p6, 3s1. Correct? So 2, 2, 4, 4 plus 6, 10, 11. Yes, correct. So that means here also valency electron, the electron which is present in outermost orbit. Outermost orbit is 3. Okay. So here in this outermost orbit, the electron, valence electron is entering. That is entering into the S orbital. Okay, so that's why these are belongs to S block elements. The valency electrons enter into S orbital. Those elements are nothing but you can say S block elements. S block elements. Here in this, generally this group 1A elements. Group 1A elements of periodic table called as alkali metals. Alkali metals. These lithium, sodium, potassium, rubidium, cesium, francium. This color is a dark pink color. Alkali metal. Okay. So alkali metals. In the same way, group 2A. Group 2A elements. Group 2A elements are these beryllium, magnesium, calcium, strontium, barium, radium. So these are alkaline earth metals. Alkaline earth metals. From these, what you can get idea? So metals are in the left side. So you can note down metals are in left side. Okay, metals are basic in nature. Basic in nature. Okay, and in the same way, carbon, nitrogen, oxygen, phosphorus, sulfur, selenium, all these are considered as non-metals. Non-metals. Non-metals are in right side. Right side. These are acidic in nature. Acidic in nature. Okay. So noted all these group 1A elements are alkali metals, group 2A elements are alkaline earth metals. Okay. So these are metals are electropositive nature, correct? Those are having electropositive nature. Electropositive nature. And also these metals are, one more important point, metals are basic in nature. Basic nature. Okay. Now coming to P block elements. Students, this topic is somewhat of boring, but you have to listen only. Okay, it is also very important. P block elements. Okay, so note down the point. In these elements, valency electrons enter into p orbital. Enter into p orbital. So the electron configuration is like electron configuration is like in the order of ns2 np from 1 to 6. 1 to 6. Let us take an example, then you will get idea. The group 13 to 18. Group 13 to 18. That means 3A to 8A. 3A to 8A are belongs to P block. 3A to 8A are belongs to P block. So what are those? Here 3A to 8A, 3A, 4A, 5A, 6A, 7A, 8A. So these are belongs to P block elements. Okay. So in this P block, if you can consider aluminium, gallium, indium, and also boron, silicon, germanium. So aluminum, gallium, indium, these are metals. Boron, silicon, germanium, these are semiconductors. Carbon, nitrogen, oxygen, phosphorus, sulfur, these are non-metals. Here fluorine, chlorine, these are also non-metals. Helium, neon, argon, xenon, these are noble gases. So all are present. All are present in this P block. So note down that point. It is the only group which contains metals, non-metals, semiconductors, metalloids, noble gases. Okay, contains almost all. Almost all. Now coming to D block elements. D block elements. Okay, D block elements. So let us take one example. I have forgotten to give the example. Let us take any one element of that. So let us take boron. Let us take boron. Atomic number is 5. So if we take boron, atomic number 5. So what is the configuration? 1s2, 2s2, 2p1, 2p1. So that is outermost orbit is 2. In that, what is the valence electron here? The valence electron enter into p block. So p orbital. Enter into the p orbital. So that is belongs to p block. Okay. Belongs to p block. In the same way, d block elements. Here note down the point. Valency electron, same like previous, enter into in the s block s orbital, p block p orbital, d block d orbital, enter into d orbital. Very simple. Okay, and here electron configuration n minus 1 of d from 1 to 10 and ns 1 to 10. Okay, here this block contains of group 3 to 12, 3 to 12 of the periodic table. These are considered as, these are called as, these elements are called transition elements. Called transition elements. So what are these? Group 3 to 12. So 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So these are D block, sorry, D. D block elements. So from this one to this one, P block. These two are S block. Okay, S block. Now finally F block. F block elements. Okay, the F block consists of two series. What are the two remaining series we have? That is lanthanoids, actinoids. Okay, actinoids. These are nothing but F block elements. A very simple, guys. First group 1A, 2A belongs to S block, and 3A, 4A, 5A, 6A, 7A, 8A belongs to P block. Okay, and 3B, 4B, 5B, 6B like that. That means 3 to 12 belongs to D block. Belongs to D block. And the remaining lanthanoid actinide series belongs to F block. F block. Okay. Now after this, we want to discuss some important terminology. Some important terminology in this periodic classification of elements. Okay. Some important terms. Let us take atomic size. What is this atomic size? Atomic size is nothing but the radius of atom. The radius of atom. Okay, if the radius is like R1, and if it is one more element having the radius this much of radius, R2. So R2 is greater than R1 means the atomic size of R2 is greater than atomic size of R1. So then atomic size of R2 is greater than atomic size of R1. Okay. So if the radius is more, the atomic size is also more. Now coming to the second important term, ionization potential. Ionization potential or energy. We can denote with IP. What is this ionization potential? It is the potential or energy. It is the potential or energy required to remove one electron from outermost orbit. To remove one electron from outermost orbit. So note down. It is the energy required to remove one electron from outermost orbit. Okay, from outermost orbit. For example, let us take any element, sodium, atomic number 11. So configuration 1s2, 2s2, 2p6, 3s1. So what is the outermost electron? That is 3s1. So that is the electron present in 3s1. So if we want to remove one electron from this outermost orbit, we require some energy. That energy is nothing but ionization potential. That energy is nothing but ionization potential. Okay. Now here generally, if any element participate in the reaction, we can easily remove one electron. Okay. If any element is participate in reaction, we can easily remove one electron. If that element is not at all participating in the chemical reaction, that is very difficult to remove electron. Correct or not? For example, let us take here one boy A, another boy, let us take a B. This person is highly talkative. So highly talkative, that means highly reactive. Here this person is not at all talking with any friends. He don't have any friends. He don't want to talk with others also. Non-reactive. Okay. Now it is very easy to take one chocolate from the person A. Am I correct? He has so many chocolates. It is very easy to take one chocolate from the person A. Why? Because he is very reactive. That means very friendly nature. He is ready to make friendship with anyone. So that's why we can easily take one chocolate from him easily. But he is not, the person B is not at all talking with any others. If he is not talking with any others means, if you want to take one chocolate from him means very difficult, na? He is not at all talking with any others. So if we ask the chocolate, he may not give. So it is very difficult. That is a difficult task. So we have to put more effort. That means here also, if any element is highly reactive, the ionization potential is very less. Less energy is required. If any element is not at all participate, the ionization potential is more. So we can say highly reactive elements having least ionization potential. Okay, highly reactive element, for example, cesium. Cesium is the highly reactive element that having least IP. And non-reactive elements. What are the non-reactive elements? Generally, you can say noble gases having highest IP. For example, helium, neon, argon, lights. These are non-reactive elements, so highest of ionization potential. These are very important, guys. They will ask simply the question in the following, which is least IP. If we know the concept, highly reactive elements easily participate. We can easily remove one electron from that outermost orbit. So we can easily give the answer cesium. Okay, not only cesium, that is these elements highly reactive. Sodium, potassium, rubidium, cesium. So these are highly reactive elements. So we can easily remove one electron from that. So less energy is required. So least IP. And noble gases, highest ionization potential. Okay. Coming to the next one. Third one, electron affinity. Affinity or affinity. So we can call in any manner. But generally we denote EA. So that's why affinity. EA. It is somewhat of opposite to IP. Okay, in the IP, energy required to remove the electron. Here, affinity, if we add electron, how much energy is released? If we add one electron to the neutron atom, the amount of energy released is nothing but electron affinity. Okay. So note down, energy released when an electron or when an extra electron is added to the atom. Okay, energy released when an extra electron is added to the atom. Here, highest electron affinity, highest electron affinity is nothing but chlorine, nothing but chlorine. Okay, highest electronegative nature, electronegative nature, that is fluorine, that is fluorine. Here the concept is, if that is the energy released when electron is added to the atom, correct? EA is nothing but, for example, if you can consider it is one atom. If you add electron to this one, then energy is released. Correct? If we want to add the electron to the atom, this atom has to attract that electron. Correct? Whenever this atom attracts that electron, then only energy is going to be released. So this atom must be having attracting property. Attraction of electrons. It must having the property that it must attract the electrons. Which are attracting electrons? Electronegative natures. Electronegative nature. What is the meaning of electronegative nature? That is a property of attraction of electrons. Okay, so if the elements are having most electronegative, that is nothing but like a fluorine, chlorine. So these are sulfur. Okay, so these are electronegative nature. So fluorine has to attract more electrons, then more energy has to be released. So we have to give the answer. Highest electron affinity is fluorine. But why I am giving instead of fluorine, why I am giving chlorine? Because the size of fluorine is greater than size of fluorine. So that's why highest electron affinity element is nothing but chlorine. Okay. So in the MCQ session, I will give in detail discussion on this. Okay. No need of worry. So while discussing the practicing question, I will give in detail. Okay. So up to now, note to make highest electron affinity chlorine, highest electronegative nature is fluorine. Okay. After this, now I want to give some important points, highest and lowest, highest and lowest properties of some elements. Okay. Here the first one, lightest metal, which is called as lightest metal, lightest metal or lightest element, not element, lightest metal. Lightest metal is nothing but lithium. So that's why lithium is used in the batteries, portable batteries, that is mobile batteries, laptop batteries. Those are lightweight now, lightweight. So we are using lithium. Okay. And if they are asking just lightest element, lightest element, in that case, that is we are going to give hydrogen. Hydrogen. So generally, if they are asking lightest element or lightest non-metal case, that is hydrogen. If they are asking heaviest element, heaviest element, that is osmium. Osmium is very heaviest element. So here the lithium is the lightest. Okay. And here lightest. If you consider non-metals, that is the hydrogen is the non-metal. Okay. And coming to heaviest, that is osmium. If they are asking the question liquid metal, generally metals are in solid nature na. What is the liquid metal? Mercury. Mercury is the liquid metal. If they are asking liquid non-metal, liquid non-metal, that is bromine. It is also very important. Bromine. Best conductor, that is silver. If they are asking best conductor in non-metals, especially non-metal. In non-metal. In the non-metal, which is the conductor? Graphite. Okay. Most ductile metal, that is gold. We can make very thin wires by using the gold. Okay. Most reactive element or reactive metal is cesium. Cesium is the most reactive metal or element. Okay. And highest ionization, just now I have given highest ionization, highest ionization potential, which is noble gases, helium. Least ionization potential, which is having highly reactive, that is cesium. Cesium. Okay. Metal having highest melting point, that is considered as tungsten. That's why it is used in making of filaments. Okay. Highest electron affinity. Electron affinity. Already given na chlorine. Most electronegative nature, that is fluorine. That is fluorine. Okay. And the remaining will be discussed in the MCQ session. Okay, so these are very repeated and some less important points are also there. Those will be discussed in the MCQ session. Okay, and one more thing, some type of questions we may get, those are nothing but electronegative nature, electropositive nature, atomic size, electron affinity. Those will be decreases or increases while in the periods or in the groups. Those type of questions are also we are getting. Okay, so let us take those points. Let us take those points. Characteristics of periods. Characteristics of periods. Here, what is the main characteristics? The first one, the number of valency electrons in elements increases from 1 to 8. 1 to 8. Increases from 1 to 8. That is 1 to 8. That is moving from left to right. From left to right. Okay, for example, if you can consider here lithium, how many valence electron? It has only one valence electron. So like that, if you are going to left to right, beryllium, it has 2, and boron 1s2, 2s2, 2p1 now, so that means it has 3 valence electrons. Like that, valence electrons will be increases from left to right. Valence electrons are increases from left to right. And now coming to atomic size. Atomic size, electropositive nature, metallic nature. We know very well electropositive, which are having electropositive nature, Electropositive nature means is a property of donating electrons. Donating electrons. Whenever they donate electrons, that will becomes positive. Okay, electropositive nature. Which are donating the electrons? Those are nothing but metals only, na? And we know very well metals are nothing but basic in nature. So all electropositive nature, those are nothing but metals. Metals are nothing but basic in nature. So basic nature. What happened to all this? Basic nature. Basic nature. All these are basic nature are increases or decreases from left to right in the period, or decreases from left to right in the periods. Okay, left to right in the period. For example, let us take lithium, sodium, potassium. These are metals. So metallic nature is higher in the left side. So left to right. In the right side we have fluorine, chlorine, bromine. So that means these nothing but you can say non-metals. So metals to non-metals means metallic nature is decreases. Metallic nature decreases means basic nature decreases, and electropositive nature also decreases. Okay, those opposites will be automatically increases. So that is nothing but opposite of electropositive nature, electronegative. So electronegative nature, metallic nature place, opposite of metallic nature, non-metallic nature. Basic nature in the sense here acidic nature, and also ionization potential, highest ionization potential, which side? Non-metal side only, na? So non-metallic nature in the sense that is also having highest ionization potential. And in the same way, electron affinity, electron affinity, so which is highest electron affinity element? Electron affinity, electron affinity, it must has to, if we add the electrons, the energy released, so it must having to attract the more electrons. So electron affinity is nothing but you can say here which is attracting more electrons. So that is fluorine. Fluorine is in which side? Fluorine is in which side? It is in the left side. So it is also from fluorine is in the right side. So it is also decreases from left to increases from left to right. So if I would note down that point, this is also same. So all this electronegative nature, non-metallic, acidic nature, ionization potential, electron affinity, all will be increases from left to right. Left to right. Okay. Simple thing, guys. I want to say simple thing. Just it is the periodic table. Okay. If I erase all this, all link on this slide. Yes. Okay. Yeah. Lithium, sodium, potassium, beryllium, magnesium, calcium. We consider all these metals. So the first one, metals are in the left side. Okay, this is the left side. This is the right side. So here carbon, nitrogen, oxygen, phosphorus, sulfur, fluorine, chlorine. These are non-metals. So here we have non metals. Metals are having electropositive nature. Electropositive nature. And metals are also having basic in nature. So those are bases. Non-metals are electronegative, negative, and this electronegative and non-metals are also considered as acidic nature. Okay, so from this, what you got, guys? Metals are electropositive and basic nature. Non-metals are electronegative and acidic nature. So metals are in the left side. Non-metals are in the right side. So from left to right, water decreases. These metallic nature, electropositive nature, basic nature, all will be decreases. Now these are highest in the left side. Whenever they are coming from left to right, which are decreases? All these metallic nature, electropositive nature, basic nature are decreases. Now, so that is the point I have given here. That is the point I have given here. Electropositive nature, metallic nature, basic nature are decreases from left to right in the period. Getting my point? Opposite. Opposite. What are the opposite? Opposite of this right side. Acidic nature, non-metallic nature, electronegative nature. These are in the left to right side. Right side means left to right all will be increases. And which is the highest electron affinity? Electron affinity. Chlorine. That is in the left. That is in the right side. Helium. That is also in the right side. Helium highest ionization potential. So IP also highest in the right side. EA also highest in the right side. That means left to right. IP and EA are increases. That is the point I have given here. That is the point I have given here. Electronegative nature, non-metallic nature, acidic nature, ionization potential, electron affinity, all will be increases from left to right. Clear? In the same way, I want to give characteristics of periods. I know the session is going to be very lengthy, but I want to complete. Okay, so many students are messaging, sir, please complete the syllabus as early as possible. So that's why I want to complete all this. Now coming to characteristics of groups, note down the point. All the elements of a group of periodic table have same number of valency electrons. Very important question. Same number of valency electrons. Very important point. Okay, and here coming to atomic size, electropositive nature, same like previous. Electropositive nature, electropositive, that is metals, metallic nature. Metals are bases, so basic nature. What happened to all this in the group means top to bottom. Okay, whenever coming to top to bottom, increases or decreases? Top to bottom. So here in case of electropositive nature, basic nature, metallic nature, if you can consider all these, sodium is more metallic than lithium. In the way, same way, potassium is more metallic than the sodium. So that means top to bottom it is increases. Top to bottom means it is increases. So we can note down the point. Top to bottom increases. And which are decreases, guys? Opposite. Electropositive nature opposite. Electronegative nature. Negative nature. Non-metallic nature. Acidic nature, electron affinity, and also ionization potential. Let us take all these. Ionization potential highest in the top side. Electron affinity is also in the top, in the bottom less. So that means top side we have highest electron affinity and highest ionization potential. That means top to bottom it is decreases, correct? Top to bottom decreases. Okay, and acidic nature. So if you can consider hydrogen is in the top side. Okay, chlorine is also acidic in the top side. Okay, so from top to bottom acidic nature also decreases. So all will be decreases. All will be decreases. Okay, so got it. So from the periodic table only we can get the answer of all this. Okay, you have to keep in mind this one. Generally that is hydrogen, lithium, sodium, potassium, rubidium, cesium. These type of metals are in the left side, right side non-metals. If you know that one, you can give answer for all these type of questions. The main important metals left side, non-metals right side. Okay, so metals are electropositive nature, though that is nothing but basic in nature. Non-metals electronegative, that is acidic in nature. Okay, those are in the right side. Okay, all of you getting? And don't worry, we will also discuss the MCQs. From that you can get in detail idea. Okay. Okay, students, if you like my classes, if you like my effort, don't forget to click on the like button. Okay, and also please share to all your friends. Here very less students watching means my efforts will be just wasted. Okay, so try to share. Okay, thank you so much, guys.